Welcome to our ME452 interim presentation. My name is Anna Tmafichuk, and we'll be presenting Christopher Miziono, Benjamin Schmessing, Jared Shattuck, and myself.
Our chosen product was the quadcopter, and for the product description, obviously it's to take aerial photos or videos. Should be lightweight, easy to use, durable, long lasting, long range of use, so that you can still control it. Um, Multiple fly modes for the casual and the more competitive. Um, Safe to use and also can handle multiple environments like gusts of wind and stuff.
Looking at both the primary and secondary consumers, for our primary group of consumers, it would typically be your average person or hobbyist that's looking at the drone for simple pleasure or perhaps photography. However, on the other hand, our secondary consumer would be individuals or teams looking for a robust and lightweight and very fast drone that's capable of performing stunts or other various maneuvers.
Here we have the functional analysis. We started with the fact that we want to fly a quadcopter. We want it to take video, we want it to fly around, we want it to extend its flight, retain control, and we want to assure dependability no matter if we're talking about the primary or the secondary consumers.
Assembly sequence analysis, we decided to go with a build from the ground and a combined sub-assemblies. The build from the ground is assembly number one, and it was more starting with the spider base plate, kind of then building from the inner to outer. So we just kind of put the arms on and then attached everything else, added the motors, and then we had the full quadcopter. While the assembly one, we built all the arms, which there's 4 identical arms within it, which is adding like the motor, spinner, fan, and all those other components of the arm. And then we added that to the inner parts, and then we got our second assembly. In comparing the two assembly sequences, we came up with that sequence 2 is more effective based on the criteria. Um, and this was mainly due to the fact that the ease of like fastening the joints was much easier in the second assembly, since you could rotate the arm while attaching everything, while once you've put the arms on, it's a little harder to rotate around to get to the underbelly of the actual quadcopter. Also, the ease of assembly in parallel also was definitely in the favor of the sequence 2. And then also ease of testing sub-assemblies was also in the favor of sequence 2, which came to a total of 14 to 11. And sequence 2 was the one that we built from the outer to the inner, which was more putting the sub-assemblies into the center part.
Now looking at the function component matrix, on the left-hand side we can see the 11 various parts that consist of the entire drone assembly. We can also see the top row that consists primarily of all of the terminal functions that were derived directly from the functional analysis table as seen in the previous slide. Some parts, such as the motor, have a total of 4 total functions, while some have very little, such as the battery, which only has 1.
For the top-level BOM and cost estimation, we try to approach it from a point of view of what we would actually be manufacturing and whether we would be redesigning it or not. For this specific quadcopter product, we would be designing the spider base and the spider top, including the arming assembly, and we'll be keeping all of those parts but redesigning them ourselves and buying everything else off the shelf, including the battery and the avionics package. When looking at the BOM for the arm assembly, we would be buying the motor off the shelf and everything else, including the fan and the electrical connector, but we'd be making the pillar stand in-house and the spider arm. The spider arm we would be redesigning for ease of manufacturing and cost, but we would be eliminating the pillar stand because we would want to integrate it with the rest of our manufacturing process.
Looking at the function differentiation table, we can see a list of attributes pulled directly from the functional analysis chart. Now, looking at the primary and secondary consumers, their wants and needs will be vastly different between each other. For instance, looking at efficient battery and efficient motor control, for the secondary consumer, they'd be looking for a high power, high output type of battery and motor. However, the more retail primary based consumer would be looking for a long battery life and long lasting battery. Looking at the component commonality table, we can see that the components are directly derived from the functional differential table as well as the function component mapping matrix. On the left-hand side with the platforms, we have a list of various parts that are going to be same for the two variants. However, on the right-hand side, we're going to have modular parts that will be changed out for the variants in order to accommodate our primary and secondary customers more thoroughly.
Based on our function differentiation table, we were able to generate a new design for our secondary customer base. Looked at the primary source of lift and mechanical power for the system. Fan is the primary method of lift, and changing the design to a quad-bladed design would allow for enhanced performance for our secondary customer group. Motor is also swapped for a higher efficiency motor, shown through the increased amount of heat dissipation elements. Spinner is the method in which the mechanical work is transferred to the fan blades and acts as a common interface between the two variants. This view shows the variations in the assembly nature between the two variants. Our primary variant uses a locking nut to secure the fitted fan onto the spinner. The secondary variant uses a press fit with snap fittings to tightly secure the spinner onto the fan blades. This allows for increased stability and secureness for the performance-based fan.
Looking at the assembly sequence, we can see the flow of production for the primary as well as the secondary variants of the quadcopter. Looking at the initial three components, the spider base, avionics package, and spider arm, we can see that it is the same for both variants. However, once we get to the motors between the primary and the secondary are both different, so that's why we see that branch out as it continues onwards and finishes off with the battery.
Thank you so much for your time. We're really sorry we turned this in late. There was a lot of internet connectivity issues, and we hope you have a great day and a wonderful Memorial weekend. And we look forward to your feedback. Thank you!